In this lesson, I'm going to go over questions off of the Test 4 study guide. This test is going to cover all of the polynomial sections. So we are going to learn about our properties of exponents and our adding, subtracting, multiplying, and dividing of polynomials. So we're going to start off, I've actually combined sections 5.1 and 5.2 with positive integer exponents. I've already combined those two sections in this first set of problems. So just so you guys know that. Your test will consist of approximately 20 to 35 questions. There are so many examples on the study guide just so you have an actual chance to have enough practice to make sure that you're successful on this test. Don't forget that your homework is due the day of the test, so don't forget about that. Okay, so write each expression in simplest exponential form. So we have to look and see what's happening with our bases. So since we are multiplying our bases, we are going to add our exponents. So that would be r to the 4 plus 9, which is r to the 13. Oops. You can still see that P, can't you? Okay, so over here, remember you do not have a simplified expression if you still have a negative exponent. So we have to get rid of that x to the negative 5. So to do that, we have to move it to the other side, which would be down to the denominator. So your 4 stays in your numerator, and you now have an x to the positive 5 in your denominator. Once you move that variable and its exponent to the other side, it becomes a positive exponent. So our answer is 4 over x to the 5th. Now on number 3, I have 2w to the negative 3rd. Well, this entire 2w is a negative exponent, so we're going to move the whole thing down to the denominator. So I have 2w to the 3rd power, and there's that 1 in our numerator. We can't just leave it blank. So that would give me 2w times 2w times 2w. So if you remember the other way in class, I taught you how to do this problem by distributing your exponent into the exponents inside of the parentheses. You can also use that method if you wish. You definitely do not have to use that method. This one will also work. I'm going to try and use a pen and see if that makes this a little bit darker and easier for us to see. So that would give me 1 over 2 times 2 is 4, 4 times 2 is 8, and then w times w times w. All of those w's are understood to have an exponent of 1, so 1 plus 1 plus 1 is w to the 3rd. I'll go ahead and make all of these answers a little bit darker now that I see the pen was a good idea. So now we're going to move on to number 4. Number 4, I've got my negative exponent of m to the negative 4th, so I'm going to move that to the other side, which in this case would be to the numerator. So I have my 3m to the positive 4, and you may keep it over 1 just because you know you had a denominator, but that's not in simplest form. Simplest form would be simply 3m to the 4th. If you were to leave your answer over 1, that would be half credit off because that's not in the complete simplest form like they're asking us to do in the directions. On number 5, I'm going to move my negative exponent to the other side. So I have y squared divided by y to the 5th. Notice your 5 is now positive since you moved it to the other side. And then 5 minus 2 is 3. Since 5 was your bigger number, your y to the 3rd is going to go into the denominator, and you have an understood 1 for that numerator, so we have to put that as a placeholder. On number 6, we have two different negative exponents. So the w to the negative 7 is going to move to the denominator, and the w to the negative third is going to move to the numerator. So I now have w to the third divided by w to the 7. So 7 minus 3 is 4, and it goes with the bigger exponent, so my w to the fourth goes in the denominator, and you have to have that 1 in your numerator as a placeholder. So we don't have any negative exponents on number 7, so we don't have to do any switching or anything like that. So 15 minus 12 is 3. And the reason we're subtracting is because when you divide your bases, you subtract your exponents. So 15 minus 12 is 3. So I have x to the third power, and then that 1 in the numerator. Remember, your x to the third went in the denominator because 15 was bigger than 12. Number 8, we're just multiplying. So when you multiply your bases, you add your exponents except for these coefficients. So you actually multiply 6 times negative 3 to get negative 18. C to the 0 times c squared. Well, 0 plus 2 is 2, so I'm left with c squared. And then d to the fourth times d squared. You add those exponents, so 4 plus 2 is 6. So our final answer is negative 18, c squared, d to the 6th. That concludes page 1 of the study guide. If I can ever get it apart. So now number 9, again, we are multiplying here. I recommend just going ahead and getting rid of these negative exponents just so they're not in our way. So we're going to move both of these to the other side, which in this case is down. So that gives me 5a squared b to the third times that 2 that was left over a squared b to the 6th. Notice your a squared and b to the 6th became positive once you moved them down to the denominator. So now I can multiply my 5 times 2 to get 10. And I have a squared b to the third over a squared b to the 6th. So your a squareds cancel because whenever you divide something by itself, it gives you 1. And when you multiply 1 times anything, you get that anything. And then my b to the third divided by b to the 6th. When you divide your bases, you subtract your exponents. So 6 minus 3 is 3. And it always goes where the bigger exponent is, so it would go in our denominator. So we would have 10 divided by b to the third. On number 10, this property is the power over power rule. So we have to distribute this 2 into all of the exponents inside of that set of parentheses. But notice that that 3 still has an exponent of 1. A lot of people forget that that 3 has an understood exponent of 1. So don't forget that. That's real important. So I'm going to distribute that 2 and multiply it by every exponent inside of that set of parentheses. So that gives me 3 squared m to the 4th n to the 6th over p to the 8. And we're not done because we can still evaluate that 3 squared. So 3 squared is 9 m to the 4 n to the 6th over p to the 8. We're finished. Okay, so on number 11, you can either move your negative exponents first and then distribute, or you could distribute and then move your negative exponents. The only reason I would recommend distributing first is because in a problem like number 12, notice you're multiplying by that negative 2. And when you do that, that's going to end up reversing everything you just did. So for purposes of that, I'm just going to distribute first. and then I'll switch everything. So that gives me n to the negative 9, n to the negative 9, m to the negative 12, n to the positive 12. So now I'm going to move my negative exponents. My m and n to the negative 9 will both move down. And my m to the negative 12 is going to move up. So the only thing I should have in my numerator is then m to the 12. And in my denominator, I should have m to the 9, n to the 9, and n to the 12. So I have 12 minus 9, because we're dividing those bases, is 3. And the m to the third goes in my numerator because 12 is bigger than 9. Then I have n to the 9 times n to the 12. Well, when you multiply your bases, you add your exponents. So 9 plus 12 is 21. So it's n to the 21. Now number 12, we again distribute that negative 2 into every exponent inside of that set of parentheses. So negative 5 times negative 2 is r to the 10, and then 4 times negative 2 is s to the negative 8. Remember, your problem is not simplified if you have a negative exponent. This is a mistake a lot of people make on this test. You have to move up to get that negative 8 a positive. So I have r to the 10, s to the 8. Remember, you want them to be in alphabetical order, so we did good there. So our answer is r to the 10, s to the 8. Same thing here. I'm going to distribute that 3, which gives me x to the 9, y to the 12, over x to the 18, y to the 6th. So when you divide your bases, you subtract your exponents. So 18 minus 9 is 9, and the x to the 9 goes in the denominator because 18 was bigger than 9. And then I've got y to the 12 divided by y to the 6th. Well, 12 minus 6 is 6, and it goes on top this time because 12 is bigger than 6 and 12 is on the top. Now number 14 is a little tricky. You are going to distribute this 3 into only the exponents inside of the parentheses it's right in front of. Okay? Because technically this parentheses has its own exponent of 1. So that 3 can only multiply into this set of parentheses. So I'm left with a to the 8 over b to the 4, and then b to the 6th over 2 to the 3rd, a to the 6th. Got that because 3 times 2 is 6, 3 times 1 is 3, 3 times 2 is 6. Now before we move on, I'm going to go ahead and evaluate my 2 to the 3rd power, and I'm going to combine everything on my numerator and denominator. So I have a to the 8, b to the 6th, over 8, because 2 to the 3rd power means 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, so that's how I got that 8. A to the 6th, b to the 4th. So now for my a's, I have a to the 8th divided by a to the 6th. So when you divide your bases, you subtract your exponents. So 8 minus 6 is 2, and it goes on top because 8 is bigger than 6. And then I have b to the 6th divided by b to the 4th. 6 minus 4 is 2, and that's also going to go on top because 6 is bigger than 4, and your 6 was in the numerator. We are finished. That concludes page 2 of the study guide. Now looking at page 3, remember we learned that anything to the 0 power is 1. So that means that this entire set of parentheses that's to the 0 power is just 1 times negative 3a to the 4th times negative 3a to the 4th. And I wrote them side by side because when you have square something, that means you multiply whatever's in front of that squared by itself twice. Well, 1 times anything is going to give us that anything. Negative 3 times negative 3 is a positive 9. A to the 4th times a to the 4th is a to the 8th, because when you multiply your bases, you add those exponents. So 4 plus 4 is how you get that 8. 16 is a doozy. Write in your understood exponents just so you don't get confused and forget them. And you distribute your power on the outside of your parentheses by every power on the inside of your parentheses. I know it starts to look messy. So that gives me 2 squared x to the negative 6th, because negative 3 times 2 gives you negative 6. Y to the negative 4, because negative 2 times 2 gives you negative 4, over 4 squared, because 1 times 2 is 2, x to the negative 10, because negative 5 times 2 is negative 10, and then negative 4 times 2 is negative 8, so that's how we get y to the negative 8. Okay, then we have 8 to the 3rd power, because 1 times 3 is 3. X to the 15 power, because 5 times 3 is 15. And then y to the 18 power, because 6 times 3 is 18. And then 4 to the 3rd power, because 1 times 3 is 3. X to the 21, because 7 times 3 is 21. And then y to the 12, because 4 times 3 is 12. Now let's move those negative exponents. And while I move those negative exponents, I'm going to go ahead and evaluate what I have for my coefficients. So 2 to the 2nd power is 4. And then 4 to the 2nd power is 16. So I have my x to the negative 10 went up top, so it's x to the 10. My y to the negative 8 moved up top, so it's y to the positive 8. My x to the negative 6 moved down to the bottom, so it's x to the positive 6. And my y to the negative 4 moved down to the bottom, so it's now y to the positive 4. And then 8 to the 3rd power. 8 times 8 is 64. 64 times 8 is 512. X to the 15, y to the 18, over 4 to the 3rd power is 64. X to the 21, y to the 12. Well, I know that 64 goes into 512 and 64. The reason I know it goes into 512 is because I just multiplied 64 by 8. So that makes that now an 8. And the 64 now a 1. And 4 and 16 simplify to be a 1 and a 4. So I'm going to go ahead and put everything over the same fraction. So that gives me 8y to the 25. I got that by adding 10 and 15 to get 25. And then y to the 26th, because 8 plus 18 is 26. Oh crap, that was an x to the 25, not a y. And sorry guys, this is what happens when you use a pen in math. So I have 8x to the 25, y to the 26th, over 4 x to the 27, because 6 plus 21 is 27, y to the 16, because 4 plus 12 is 16. Now I can simplify the 4 to go into the 8 2 times. So I'm left with a 2 in my numerator. 27 minus 25 is 2, and the x squared goes on bottom because the 27 was bigger than the 25. And then 26 minus 16 is y to the 10, and the 10 goes up top because 26 was bigger than 16. Okay, so now we're going to determine which expressions are polynomials. This is leading into section 5.3. So I know that it is not a polynomial if we have a radical, if we have a variable in the denominator, and if we have an exponent that is a fraction. So those are the three things we need to look out for. Well, none of those criteria are in 17, so we would write polynomial. There's no variable in the denominator, no radical, and no exponent that's a fraction, so 18 is a polynomial. But number 19 is not a polynomial because of that variable in the denominator. (20) is not a polynomial because of that square root, that root in the expression, so we would write not a polynomial. And then number 21 is not a polynomial because it has a fraction in the exponent. That concludes page 3 of the study guide. Okay, for each polynomial, list the terms and the coefficients. Remember, terms are separated by addition signs, so when we look at number 22, we see we have a subtraction sign. We know we can change that by using our rule, keep, change, opposite. So we're going to keep the 4x to the third. We're going to change the subtraction to addition. And you do the opposite of 2x squared, which is negative 2x squared. So my terms are 4x to the third, negative 2x squared, and 1. Remember, when you are writing terms, when they're asking you to actually list the terms, you should separate those terms with commas. And then when they ask you for the coefficients, you will have the same number of terms as you have coefficients. So since there are 3 terms here, I should have 3 coefficients. So I should have coefficients of 4, negative 2, and 1. Remember, on this 1 here, there isn't a variable written, but it's understood to have an x to the 0 at the end. Number 23, my terms are negative 7x squared and x. And my coefficients are negative 7 and 1. Remember, there's that imaginary 1 in front of the x. And then on number 24, I have 7x to the 4th, and my coefficient is 7. So classify each polynomial as a monomial, binomial, or trinomial where possible. So I have a monomial is 1 term, a binomial is 2 terms, and a trinomial is 3 terms. If they have 4 or more terms, we would write not classified, because they haven't told us what 4 or more terms are, so we would say not classified. So 25, I have 2 terms, so it is a binomial. 26, I have 1 term, so it is a monomial. 27, I have 1, 2, 3 terms, so it is a trinomial. 28, I have 1, 2, 3, 4 terms, so we would write not classified. And then on 29 we have 2 terms, so we would write binomial. So now we have write each polynomial in descending order, give its degree, and identify the leading coefficient. So descending order means you have the highest exponent to the lowest exponent from left to right. Well, on number 30, they've already put it in that descending order for us because we've got a 5 for an exponent and a 2 for an exponent. 5 should be on the left, the 2 should be on the right, so that's already in that descending order. Please notice that when they ask you to write the polynomial in descending order, they are asking you to actually write the polynomial. They just want you to rearrange the terms so they're in the correct order. They are not asking you to list. Some people like to separate these terms with commas. That is not correct. By separating them with commas, you're just listing them in order. But they want you to actually write the polynomial, so there should be no commas here. Then your degree is your highest exponent, so that would be 5. And your leading coefficient is the coefficient in front of the term with the degree, so it would be a 5 as well. Descending order for 31 is very simple. It's 13x squared because it's just one term. It's a monomial. Your degree is your highest exponent, so it would be 2. And your leading coefficient is 13, the coefficient in front of the variable. Now we should have my x to the 4th first, my x squared second, and then your number by itself called a constant, that would always go last, because remember, by the problem we did up here, if it's just a number by itself, it has an x to the 0 at the end. So a 0 exponent would surely be smaller than any of these others. So I would write 4x to the 4th plus 6x squared plus 6. Your degree is 4 because that's your highest exponent. And your leading coefficient is 4 because that's the coefficient in front of your degree. That concludes page 4 of the study guide. Moving on to page 5. Well, this is understood to be an x to the 1st. So that should be x plus 5 for my descending order. My degree is 1 because the understood exponent here is a 1. And then your leading coefficient is also a 1 because the number understood to be in front of that term is also a 1. 34 is -8. It's a monomial, so we would just write it as just that one term. Your degree, remember, just like we said on the other page, if it's not written, it's understood to be an x to the 0 at the end. So your degree would be 0. And the leading coefficient would be -8 because that -8 is in front of that x. Then, for number 35, the x to the 6th comes first, the 9x to the 4th comes second, and the -3x comes third. So I have 7x to the 6th, and then I have my 9x to the 4th, and then I have my -3x. Your degree is 6. It should always be the biggest exponent. And your leading coefficient, the number in front of your x, should be 7. That's always the coefficient with your degree term. Now, moving to addition and subtraction. First thing we should do is put these in our parentheses form. So that gives me 7a squared plus 3a plus 14a squared minus 5a. And now we need to ask ourselves those questions to see if we can release these from those parentheses. So can I combine these two terms? No. Is there anything other than that 1 multiplying out in front? No. So I have 7a squared plus 3a. And then can I combine these two terms? They're not like terms, so no. Is there anything multiplying out in front? No. So I can go ahead and release that from the parentheses. Now I combine my like terms. 7a squared and 14a squared is 21a squared. 3a minus 5a is negative 2a. Now, same thing for 37. I'm going to write it in my parentheses form. And then I have to ask myself those two questions again. Can I combine any of the terms inside of that set of parentheses? No. Is there anything multiplying out in front? No. So I go ahead and release this from that set of parentheses. Can I combine any of these terms in this set of parentheses? The answer is no. Is there anything multiplying out in front? No, not other than that one. So I can release that from the parentheses. I can combine my like terms. 5x squared plus 4x squared is 9x squared. 3x minus 6x is negative 3x. And then negative 5 minus 2 is negative 7. Now number 38, I've got 5y to the third minus 3y squared plus 4y plus 3y squared. Can I combine these two terms? No. Is there anything multiplying out in front? No, so I can release it from that set of parentheses. And then can I combine these two terms? No. Is there anything multiplying out in front? No. So I can release that from the parentheses. Now remember, you have to put this in that descending order, so look for your biggest exponent first. So my 3 is my biggest exponent, and it doesn't have any other like terms. So we just write that as 5y to the third. And then I've got a negative 3y squared plus 3y squared. Well, negative 3 plus 3, those just give you 0. So they cancel out. And then bring down that 4y. '39's a little bit different. Do not forget that you have to switch these two terms, or these two sets. So I'm subtracting this from this. So remember, we have to write our 11x squared minus 15x first, and then our 7x squared minus 23x. If you don't remember why we do this, please visit the notes from section 5.4. I can't combine these two terms, and there's nothing other than a 1 multiplying out in front. So my 11x squared minus 15x can be released from the parentheses. Now I can't combine these two terms on the inside, but there is a negative 1 multiplying out in front. So I'm going to distribute into that set of parentheses. So negative 1 times 7x squared is negative 7x squared. Negative 1 times negative 23x is positive 23x. So 11x squared minus 7x squared is 4x squared. And then negative 15x plus 23x is 8x. That concludes page 5 of the study guide. Now looking at page 6, I'm going to set this up the same way. So remember, this is going to be written first, and then this is going to be written second. So I have 7x squared minus 2x plus 3 minus 2x squared minus 5x minus 7. I can't combine any of these terms. There's nothing multiplying out in front, so my 7x squared minus 2x plus 3 will be released. I can't combine any of these terms, but there is a negative 1 multiplying into each term. So I have negative 1 times 2x squared is negative 2x squared. Negative 1 times negative 5x is positive 5x. Negative 1 times negative 7 is positive 7. Now I can combine my like terms. 7x squared minus 2x squared is 5x squared. Negative 2x plus 5x is 3x. And then 3 plus 7 is 10. So I have 5x squared plus 3x plus 10. So now I'm going to subtract these. So I have my 9x squared minus 4x minus 5x squared plus 3x. Oh, just 3. So now I can't combine these two terms, and there's nothing multiplying out in front, so I can release this expression from the parentheses. And then I can't combine these two terms, but there is a negative 1 multiplying out in front. So I'm going to distribute that negative 1 into both terms in that set of parentheses. So negative 1 times 5x squared is negative 5x squared. Negative 1 times 3 is negative 3. So now I'm going to combine my like terms. 9x squared minus 5x squared is 4x squared. Then I just have a negative 4x. And then your negative 3 is at the end. So now let's move on to multiplication. So for number 42, I'm going to multiply my coefficients. So 3 times 2 is 6. And then when you multiply your bases, you add your exponent. So 4 plus 3 is 7. So that gives us 6a to the 7th. On number 43, this is our distributive property. So we are going to multiply that 5 times each term in our set of parentheses. So that will give us 5 times 3x is 15x, and then 5 times negative 8 is negative 40. So now on number 44, we are going to distribute this 2a into each set of our parentheses. So 2a times 5a is 10a squared, and then 2a times negative 3 is negative 6a. Then on number 45, going to again distribute the 7mn into each term inside of my set of parentheses. So 7 times 3 is 21. M times m squared is m to the third because that m has an understood 1 there. And then n times n is n squared. So 7 times negative 2 is negative 14. M times m is m squared because these both have understood 1s. And then n times n squared is n to the third because that's a 1 plus 2 gives you 3. Then 7 times 5 is 35. M times m is m squared. N times n is n squared. And there are no like terms here, so that is our answer. Okay, now in 46, again, you might know this as the FOIL method, but I do not teach it that way. So you multiply this first term in that first set of parentheses times everything in your second set of parentheses. And then you multiply this second term by everything in that second set of parentheses. So W times W is W squared. W times negative 10 is negative 10W. Negative 9 times W is negative 9W. Negative 9 times negative 10 is positive 90. Now I can combine these two middle terms to get W squared minus 19W plus 90. Remember, because negative 10 minus 9 is negative 19. That concludes page 6 of the study guide. On page 7, again, we distribute this A into each term in our set of parentheses, and then this 4B times each term in our second set of parentheses. So A times A is A squared. A times 3B is 3AB. 4B times A is 4AB, and you always write it in alphabetical order. That's why I did that AB. And then 4B times 3B is 12B squared. So then I'm going to combine these two terms, which would give me A squared plus 7AB plus 12B squared. Then on number 48, A times A gives me A squared. A times 9 is 9A. Negative 9 times A is negative 9A. Negative 9 times positive 9 is negative 81. Then, when I combine my two middle terms, you'll notice that they will cancel, leaving me with A squared minus 81. For number 49, we've got P minus 3Q squared. So to do this problem, we actually have to write that P minus 3Q side by side twice, because that's what you mean when you square something. That means you multiply something by itself. So that gives me P times P is P squared. P times negative 3Q is negative 3PQ. Negative QP, let me try that again. Negative 3Q times P is negative 3PQ. And again, I put it in that order because we want it in that alphabetical order. And then negative 3Q times negative 3Q is a positive 9Q squared. So now I can combine my like terms to get P squared minus 6PQ plus 9Q squared. So on number 50, we are going to still use the distributive property. But the difference in this problem is that we are going to multiply this B times everything in this set of parentheses and this 3 times everything in this set of parentheses. So B times B squared is B to the third. B times negative 5B is negative 5B squared. And how we're getting these exponents is we're adding our exponents because we're multiplying those bases. And then b times negative 7 is negative 7b. Then I multiply 3 times everything in this set of parentheses. So 3 times b squared is 3b squared. 3 times negative 5b is negative 15b. And then 3 times negative 7 is negative 21. Now I'm going to combine my like terms. So I don't have any other like terms with the b to the third, so I'm just going to carry that down. And then I have my negative 5b squared and my 3b squared to get negative 2b squared. And as I use these, I'm just going to cross them out. And then I have negative 7b minus 15b is negative 22b. And then we have our negative 21 left. Now let's move on to number 51. Number 51, we are going to multiply the m squared times everything in this set of parentheses and the negative 3 times everything inside of this set of parentheses. So m squared times m squared is m to the 4th. M squared times 7 is 7m squared. Negative 3 times m squared is negative 3m squared. Negative 3 times 7 is negative 21. Now I can combine my like terms. So I have m to the 4th plus 4m squared, because 7 minus 3 is 4. Bring down your minus 21. Now we're going to look at number 52. Number 52 is quite a beast. So what we're going to do is multiply our x to the 3rd times everything in this parentheses, our negative 3x squared times everything in this set of parentheses, our 5x times everything in here, and then our 1 times everything in here. So x to the 3rd times 2x squared is 2x to the 5th. X to the 3rd times 4x is 4x to the 4th. X to the 3rd times negative 1 is negative x to the 3rd. Then negative 3x squared times everything in here. I'm going to cross out that x to the 3rd because we just multiplied that by everything. We're done. So negative 3x squared times 2x squared is negative 6x to the 4th. Negative 3x squared times 4x is negative 12x to the 3rd. Then negative 3x squared times negative 1 is a positive 3x squared. Now I'm going to multiply my 5x times everything in this set of parentheses. So 5x times 2x squared is 10x to the 3rd. 5x times 4x is 20x squared. 5x times negative 1 is negative 5x. Now I'm going to multiply my 1 times everything. So 1 times 2x squared is 2x squared. 1 times 4x is 4x. And then 1 times negative 1 is negative 1. So now we've multiplied everything. Now we have to combine our like terms. Well, I only have 1 2x to the 5th. So I'm going to go ahead and cross that out. And then I've got a 4x to the 4th and a negative 6x to the 4th. Well, 4 minus 6 is negative 2, so that would be negative 2x to the 4th. And then I have negative 1x to the 3rd minus 12x to the 3rd plus 10x to the 3rd. Well, negative 1 plus negative 12 is negative 13. Negative 13 plus 10 is negative 3, x to the third. So I'm done with those. Now I have my 3x squared, 20x squared, and 2x squared. So when you combine all of those terms, you get 25x squared then I have my negative 5x and 4x to get negative 1x. And then finally I have that negative 1. Now if you had a problem like this on the test, it would probably be more like a bonus, but oops. If you had one like this on the test, it would probably be more like number 50 for a regular problem, and then 52 would be more like a bonus. So that concludes page 7 of the study guide. Now we're going to move to the last page, which is page 8. Okay, so on number 53, that problem and number 54 are very similar to the problems that we found in section 5.1. So we just simplify to say that 3 goes into 9 3 times, and then a to the 5th divided by a squared. 5 minus 2 is 3, so I would have a to the 3rd. Number 54, 6 goes into 24 4 times. So I have 4 m to the 4th divided by m squared. Subtract those exponents, that gives us m squared. And then n squared divided by n to the 1st is just an n. Now number 55, remember we separate these terms to be both over that same denominator. So that's 5a divided by 5 minus 10 divided by 5. Those 5's cancel. 5 goes into 10 2 times. So you're left with just a minus 2. Number 56, we would rewrite this as 32a to the 3rd over 8a plus 24a over 8a. 8 goes into 32 4 times. 8 goes into 24 3 times. So we would be left with 4a squared, because 3 minus 1 is 2. And then plus 3, and then those a's just cancel. So you're just left with that 3. On number 57, we have 9r squared s to the 3rd over 3rs squared minus 18r to the 3rd s squared over 3rs squared. I'm going to go ahead and divide these coefficients. So 3 goes into 9 3 times, 3 goes into 18 6 times. So I have 3rs, because 2 minus 1 is just an r to the 1st, and 3 minus 2 is just an s to the 1st, minus 6r squared, because 3 minus that 1 is 2, and then those s squareds cancel. So technically, if you were to write this in that descending order, you would write negative 6r squared plus 3rs. Now number 58, we've got 35x to the 3rd y squared over 7x squared y minus 21x squared y to the 3rd over 7x squared y plus 14x to the 3rd y over 7x squared y. So I'm going to divide these coefficients first. So that 7 goes into 35 5 times, 7 goes into 21 3 times, and 7 goes into 14 2 times. So I have 5xy because 3 minus 2 is that 1, and then 2 minus 1 is that 1, minus 3. Your x squareds are going to cancel, and I'm left with just that y squared. And then plus 2, x to the third divided by x squared is x, and then your y's cancel. So technically, if you were to put this in descending order, you would have 2x plus 5xy minus 3y squared. Because remember, all of your x terms should come first by the alphabetical, and then that y squared is by itself. It doesn't have any x's, so it would have to come at the very end. That gets a little tricky. So on this one, if you didn't put it in that descending order, sorry about that. If you didn't put it in that descending order, I still would have accepted it. All right, good luck on your test. Don't forget your homework is due the day of the test.